Hi everybody, today we're going to talk about uniform probability by using the example of waiting for the light to turn green. An industrial park has a side road with a weight-sensitive trigger. However, to maintain main road traffic flow, the light only checks the sensor and cycles the signal every 90 seconds. If you pull up to the sensor at a completely random time, your wait time x is uniformly distributed between 0 and 90 seconds. So how long, on average, are you sitting there idly waiting? To find our average, which is mu, we'll add 0 plus 90 and divide by 2, which gives us an average wait time of 45 seconds. Let's also talk about the standard deviation of the wait time. The standard deviation is a little trickier. We're finding the square root of 90 minus 0 squared, and we're dividing by 12, which gives us about 25.98 seconds. When you find sigma for a uniform distribution, you're always dividing by 12. So your numerator will change with the values in your problem, but the denominator will always be 12. Let's find the probability that you catch the light perfectly and wait less than 15 seconds. We'll write that as the probability x is less than 15, which is equal to 15 minus 0 over 90 minus 0, which gives us 0.1667. Let's say you've already been sitting there for 45 seconds, the average amount of waiting time. What's the probability you'll be stuck there for a worst-case scenario of more than 80 seconds? This is a conditional probability because we know we've already been sitting there 45 seconds. We're going to write this as the probability that x is greater than 80, given that x is greater than 45. To find this probability, we subtract 90 minus 80, how much time could possibly be left, then we divide by 90 minus 45 because there's 45 seconds more that can occur. When we simplify this to 10 over 45, it gives us 0.2222. 45% of the time, a driver will wait at least how long for the light to turn green? This time we're looking for an amount of time x. The words at least say we're waiting this amount of time or more. Our strategy in this scenario is not to go with the 45% that are more, but instead let's look at the 55% that are less. If we take 0.55 and multiply by 90, we get 49.5. This says 45% of the time a driver will wait at least 49.5 seconds for the light to turn green. Lastly, let's find the value of the minimum of the upper quartile. The minimum of the upper quartile is the 75th percentile. To find this value, we'll multiply 0.75 times 90 to get 67.5 seconds, which means that 75% of drivers will wait at most 67.5 seconds for the light to turn green.